Okay, guys, this is the first installment of Trig. You're going to need to take really good notes on this because this is all new stuff. And sometimes I do new stuff with in-class notes, but I decided just because we are doing hybrid, this is just going to make it easier. So I'm doing them electronically. So take really good notes. All right. Trigonometry, just so you know here. Ready? Here goes. This is how you spell it. Trigonometry. You are going to start a little bit of trigonometry. Trigonometry is the study of right triangles. And I mean, that is really all it is. It's the study of right triangles. So when we talk about trig, we're really only talking about right triangles. Did you like that? Look at that funky right triangle I just drew. Okay, let's pretend that's right. So it has to have a 90-degree angle, okay? And if you think about it, the reason why we do this is because, one, I think is just that things are naturally perpendicular to the Earth, so that's kind of the way we study it. And it's just really easy to understand similar triangles with right triangles, because look, if I draw a perpendicular, I have two similar triangles. And I can do that, obviously, to infinity, and I just can create a bunch of similar triangles. You can tell because they have all three angles the same. 90, 90, 90, 90, they all share this angle. If you share two angles, you know that that third one is going to be the same. Also, these are corresponding angles with two parallel lines. So you should know that those two are also congruent. So we have the situation of similar triangles, and just lends itself to some cool properties. So the first thing you're going to do is a word problem. And if we were all in school, we would be going outside to do this. But since we're not, you could always do this outside if you wanted to. But here's the idea is, again, that the sun is casting a shadow. We talked about that before. Okay. And so this is how the rays of the sun come in, right? And then the building blocks it, and therefore you get shadow. So the length of a shadow is 29. They're just telling you what's in the picture, you guys. The distance from the top of the building to the tip of the shadow, so the hypotenuse, is 34. Okay? Find the height of the building. They put a question mark. I'm going to put an H. All right? This is a right triangle. So when you think right triangle, I want you to immediately think trig and wait, no, we haven't learned SOHCAHTOA. That's trig. Pythagorean theorem. Pythagorean theorem. Those are going to be the most handy things you have. Sorry, there you go. Pythagorean theorem. So again, remember, I always say formula, substitution, resolution. So it says, what do you want to do? Circle the verb, find what? The height, what? Of the building. Okay. Round your what? Answer to the nearest tenth. Okay, so make sure you do that. So here's my thing, formula, substitution, resolution. So a squared plus b squared equals c squared. Remember, c is always the hypotenuse. Always the hypotenuse. So let's plug it in. 29 squared plus h squared is b equals 34 squared. And that's it. And your job is to find h. I want to show you a more advanced way to do your math. Don't plug in 29 squared into your calculator and 34 squared if you don't have to. If you have to, that's fine. If you don't understand it without doing it, that's okay. Okay? I would recommend you just subtract 29 squared, move it to the other side, okay? And you're going to get h squared equals 34 squared minus 29 squared. But we don't want h squared, remember? We want h. So we take the square root of both sides. Okay? And then these two cancel each other out. And you get rid of it. Don't bring it down. You got rid of it. Okay? Then you get h is equal to, and then you're going to plug this into a calculator. So the square root of 34 squared minus 29 squared. That's what's nice about calculators. These days, they're pretty fancy. So you can actually enter in some really nice stuff. So I could go square root of, okay, 34. It was 34. 34 squared. Well, that didn't work. Let's try that again. 34x to the y squared. There we go. Minus 29 squared. I think that's what it was. There we go. And let's see if that's right. Boom. 17.74 round to the nearest tenth is 17.7. And that's what you do. It just saves you time if you don't want to do like all the little steps in between. And especially if you get to physics, that's kind of where you want to be. You always want to solve for your variable first, and then, let's not do that. Let's try this. There we go. I'm going to move this one up. So here's a second problem. Go ahead and pause if you want to see if you can do it yourself. Okay. Here we go. I'm going to change colors because why not? All right. So this time it's sort of the same thing. Okay. So again, actually, I'm going to change this on you guys. Okay. I'm going to tell you, what if instead I made this 12? Okay. And then instead, this is the question mark. Okay. So I'm going to say a 12-foot side of the house. There I go. Ready? The 12-foot, forget the ladder, side, the 12-foot side of the house. Okay. The bottom of the ladder is 7 feet. Okay. How high is the ladder? Okay, there. I just changed the problem. All right. So again, a squared plus b squared equals c squared. So this time we don't know what c is, but we know a and b. 7 squared plus 12 squared. Okay. 49. You could do it like this, you guys. Equals c squared. And then add those two together. I just did this because I was doing it by hand. So I believe that's right. 144 plus 49, 13, 1, 9, 193 equals c squared. So I don't want c squared, I want c. So I take the square root of both sides. So it would be the square root of 193. So square root 193 equals 13 point, and round it up, 13.9. Now, of course, I changed the whole problem, so you wouldn't have the same answer if this were Alex, but whatever. The idea is that you got to be prepared for either a side or the hypotenuse, so I want you to be prepared for both. All right, so easy enough, right? That's just Pythagorean theorem, taking the square root. So again, here's some more Pythagorean theorem investigation. It says the length of the longer leg of a right triangle is 25 more than 7 times the length of the shorter leg. The length of the hypotenuse is 26 more than 7 times the length of the shorter leg. Find the side lengths of the triangle. Actually, this is a pretty tough one. And by tough, I don't know how much of your quadratics, if some of you guys if you haven't done your prerequisite with your quadratics, it's going to come back to bite you right here. So I have 3 of these problems to show you, and hopefully you'll be reminded how to do this stuff. If not, just pay attention, copy them down. Okay, the most important thing right now is I'm going to go ahead and draw this triangle just to give myself a visual. I'm so visual, I need it. So it says the longer leg. This is the longer leg, the longer leg. This is the hypotenuse. This is the shorter, this is the longer. So it says the longer leg of the right triangle is 25 meters more than 7 times the length of the shorter leg. So we're going to translate this. Okay, we did this in the very, very beginning of the year, translating these sentences. So do you see how they find the word than? So here's the word than. What are they comparing the longer leg to? It's 25 more than 7 times the length of the shorter leg. Do you see how they're comparing it to the shorter leg? Whatever noun follows than, the word than, is the one you want to pick for your variable. I'm going to call this X because they're telling you the longer leg is 25 more than 7 times the length of the shorter leg. They're comparing it to the shorter leg. So you have to know the shorter leg first. That's how you know that that's going to be your variable. So let's translate this. It says 25 more than. This is how you write 25 more than. Not 25 plus, but plus 25. Because remember, you have to add it to something. More than means add it to something. 7 times 7x. Okay. The length of the hypotenuse is 26 more than, so plus 26, 7 times the length of the shorter legs. There you go. So look at the difference. Okay, this is just one more than that one. All right, find the side lengths of the triangle. So this is going to get a little complicated, and this is tough. So in some ways, this might end up being an extra credit problem, but it's also a really good one to review for Algebra 2, so I wanted to leave it in here. All right, so we're going to start formula. Then you're going to do substitution. Now, what is A? I'm going to call A, we'll call A this one. 7x plus 25 squared. The square is not part of the side. This is the side length squared. Plus B is x squared, and C is 7x plus 26 squared. All right, I know you guys are probably tempted to take the square root of both sides. Can't do it. You can't just take the square root of both sides because there's a plus sign here. So this is going to be way more obnoxious than that. You need to do this. This is why I want you to do this one, is because it is a good one to review how to multiply binomials and how to factor. Okay, you don't have to write this out if you know how to do the square in your head, but most people don't. So here we go. I wrote it out. Square means times itself, okay? So 7 times 7, 49x squared. 7 times 25, 7 quarters. What is that? 175x plus 175x plus 25 times 25. I believe 25 times 25 is 625. Pretty sure. 25 times 25. Yep, 625. Okay, 625. And then I got to still bring down the plus x squared. I kind of spaced it wrong. I should have my equal signs lining up, but I messed up. Okay, 49x squared plus 7 times 26 is going to be, I don't know what that is. I don't want to think. Let's see, so I'll use a calculator. 182. Okay, 182x, and there's going to be 2 of those. 26 times 26, 676. Okay, so look at what we have. This looks really hard, but it's really not as hard as it seems. Okay, what they've done is they've made it so that your x squared term is going to be more simplified. So look, I could combine like terms, which is what I should do. So 50x squared plus $1.75, $1.75. 350, is that right? 175 times 2? Sorry, I'm having a hard time doing mental math today. Let's see. Yeah, 350. Okay, I'm just double checking myself, guys. Whoa, that is not what I wanted to do there. Okay, 350x. Okay, plus 625. Okay, so you see I added my x squareds, I added my x's, equals. Okay, now we want to do the same on this side. I don't have any other x squared terms, but I do have these. 182 is 364x plus 676. Okay, so now we need to get everything over to the left-hand side. You may not remember this, or you may remember this. I don't know, but when you have a quadratic, okay, you need to set it equal to 0. Set it equal to 0 and then factor. So this is hopefully reminding you how to do this. So I'm going to subtract 49x squared from both sides. I'm going to actually do this all in one step. So x squared. And then I'm going to subtract 364x. And I'm going to get negative 14x, I believe. 64 minutes, yeah. And then minus 676. So 676 minus 25 is 75, minus 25 is 50, 51 equals 0. So like I said, I don't know if you remember that that's how you solve quadratics, but this is a reminder. When you have a quadratic, you set it equal to 0. And the reason why is so that we could do this. I know this is in the prereqs. Okay, if not, hopefully we'll just get it on these next 3 examples. All right, so now you're going to try to factor it. X and X. And what 3 things multiply together to get 51? I believe 51, if you add the integers, 5 plus 1, you get 6, which is divisible by 3. So we know 51 is divisible by 3. 3 goes into 5 once. 17. Okay, so 3 times 17. And notice, I can get a negative 14 from that. I can do negative 17, positive 3. Okay, so using the 0 product rule, I'm writing the names in case you guys need to look this up. 0 product rule says this: if 2 things are multiplying and they get 0, what logically do you know about A or B? One of them has to be equal to 0. Okay, so these are my 2 things. See, I have 2 things multiplying together to get 0. So we set each of them equal to 0, and we get x is equal to 17, or x plus 3 equals 0, x is equal to negative 3. Well, here's the thing. X is a distance. Distances cannot be negative. Therefore, this answer is dumb. And that is the correct answer. 17 is the correct answer. Now, I don't know, did they ask us for x or did they ask us for what they want? Nope, they want the length. Okay, so if this is 17, let's go to black, why not? Okay, 17, then this is 7 times 17 plus 26. And this is 7 times 17 plus 25. So again, just come back to your calculator. 144 and then 146, right? So this is 144 and this would be 146. 145 rather. It's one more. Yeah, 7x plus 25, so yeah, one more. Okay. All right, now that might have seemed crazy, so we're going to do it again. I have 3 of these problems, okay? Just so that you can get used to them. So the longer leg of a right triangle is 3 feet longer than, find the word than, what? The shorter leg. That's your x. Okay, so if I draw my triangle this time, I'm going to make the x here. And it says it's 3 feet longer. That's it, 3 feet longer. The hypotenuse is 6 feet longer. There you go. Then the shorter leg, find the lengths. A squared plus B squared equals C squared. Whenever we're talking about lengths of a right triangle, you need to bring in the Pythagorean theorem. Okay, A squared is x squared. B squared is x plus 3 squared. And C is x plus 6 squared. Remember, C is always the hypotenuse, and the hypotenuse is opposite the right angle. So x squared plus, we need to multiply these 2. X plus 6, x plus 6, x plus 3, x plus 3. So use FOIL, first outer, inner, last, to get this done. Okay. Make sure you stop the video if you don't know what I just did so that you can see it. Combine like terms. These 2 are like, so you got 2x squared. These 2 are like, plus 6x plus 9 equals. These 2 are alike. Now, because we have a quadratic means with a little square, we need to get everything over, set it equal to 0. So subtract x squared. We're going to get x squared. Subtract 12x minus 6x, and subtract 36. 36 minus 9 is, I believe, 25. No, 26. No, 25. No. Wait, no, 27. Minus 27 equals 0. Okay, so how do we get 27? What two factors of 27 will help me get to a 3? So you could do 1 times 27 or 3 times 9. You can see that 3 times 9 will work. If I have a negative 9 and a positive 3, I can get a negative 6. So I can factor this. X and x minus 9 plus 3. Now I can use the zero product rule. I set each one of these equal to 0, and I get the answer. You are welcome. Remember, on the test, you can use your notes. Okay, so look, in this case, x is equal to 9. That's a positive. That makes sense. Negative 3 doesn't make any sense. So that makes, you cannot have a negative 3 distance. So this is 9. This is 12, because 9 plus 3 is 12. 9 plus 6 is 15. And there you go. And you can always tell if you got it right, by the way, by plugging it back into the Pythagorean theorem. 9 squared plus 12 squared is equal to 15 squared. A squared plus b squared equals c squared. And you will see this is 225. 15 times 15, I think. What's 15 times 15? 225. And what is 9 times 9 plus 12 times 12? 225. See? A squared plus b squared equaled c squared. Okay, there we go. So I hope you are appreciating that. This is really an equation, you guys. Literally, these two things squared and added together will equal that third side. Okay, last one. Same problem. Last one. All right. Here we go. Okay, the shorter leg. Okay, here we are back at the right triangle thing. Okay, shorter leg of a right triangle is 9 meters shorter than, here's the longer leg. In this case, the longer leg is going to be x. And we are comparing the shorter leg is 9 meters shorter than. That means x minus 9, not 9 minus x. It didn't say it's x shorter than 9. 9 shorter than x, okay? The hypotenuse is 9 meters longer than the longer leg. 9 longer than, okay? Find the side lengths. A squared plus b squared equals c squared. X squared plus, I'm going to just write it out right away. X minus 9 equals x plus 9, x plus 9. So you get x squared plus 9x plus 9x plus 81, x squared plus 18x plus 81. This is x squared plus x squared minus 9x minus 9x plus 81, x 2x squared here, and then here, minus 18x plus 81. I can subtract 81 from both sides. Again, I'm going to set it equal to 0 because it's a quadratic. Not just because, but because it's a quadratic. Okay, 81 will cancel. Subtract 18x, and I'll get negative 36x. And subtract x squared, and I'll get x squared equals 0. Okay, so this one you might be tempted to try to factor it, but you do need to factor it. But the first question in factoring is what is in common. Do you see how this is only a binomial? And do you see how they both have x in common? So we can factor out an x, and we would get x minus 36 equals 0. If you remember, you divide by x, both of these. Look, x times x equals x squared, x times 36 is 36x. All right. If this times this equals 0, then x is equal to 0, or x minus 36 equals 0. X is equal to 36. Well, it makes no sense to have a distance of 0, so that one's dumb. But it does make sense to have 36. Okay, 36 minus 9 is 27. 36 plus 9 is 45. Okay, so I could check it. Is 36 squared plus 27 squared equal to 45 squared? I don't know. Let's see. 36, 27, 45. Let's see. 45 times 45 is 2025. Okay, 36 squared plus 27. Was it 36 squared? I think. Squared. Oops. 2025. Yep. Then we know we did it right. And you got your answers correct. Those three are correct. All right. That's definitely going to be the harder one. Now we're going to have to use it repeatedly. You're going to have to use it a couple times to get what you need. That's what this whole thing is about. It says use the information given in the figure to find the length TR. So we're looking for this right here, TR. If applicable, round your answer to the nearest whole number. Okay, so nearest whole number is sometimes hard for people. So let's make sure we do that. Okay, the lengths on the figure are not drawn accurately. That's really important. That tells me don't use your eyes. Like don't use your common sense. Be like, don't do that. Okay. Okay, let's take a look. So we want to use the Pythagorean theorem to figure out this length, but we don't have it yet. You guys see that? We don't have this length yet. We want it. We want this length, but we can't figure it out yet. So how are we going to figure it out? We need another length. We have this length, okay? The question is, can we figure out one of these others? Okay, so what do we have? Let's see. What do we have? I have this hypotenuse, and I have that this is 90. Oh, here we go. Do you see this is the only triangle right here? This one right here is the only triangle with two sides. So I can use it to find this side. Okay, so let's do that. This is crazy. This is going to be a little crazy. So I'm going to do red triangle first. So a squared plus b squared equals c squared. I've got A and I don't have B. I'm going to find B, but I have C. So I'm going to go 72 squared plus B squared equals 75 squared. So B squared is equal to 75 squared minus 72 squared. And I take the square root of it, of both sides, and I get this. If that confused you, go back and look at the one we did before. Okay, so now you're going to do this. Ready? Let's go to the calculator. Square root 75 times 75 minus 72, right? Wasn't it 72? Yeah. 72 times 72. I can put it in there like that because your calculator knows order of operations. So 21. So then I get 21 for this side. Okay. 21. Now you look. I now have two sides. I have this one. So I can figure out this side right here. Okay, so I'm going to use green for this. A squared plus b squared equals c squared. A squared is the one we're looking. B squared is 21. And c squared is 29. So a squared is equal to 29 squared minus 21 squared. A is equal to the square root of 29 squared minus 21 squared. Okay, square root of 29 squared minus 21 squared. 20. So I come back here and I'm like, okay, this is 20. Oh, look, you guys. Now I can figure out this side right here. Let me get a different color. I can now figure out this one because I have two sides of a right triangle. So again, a squared plus b squared equals c squared. I've got 20 squared plus b squared, which is the length I want, equals 88 squared. B squared equals 88 squared minus 20 squared. Subtract, and b is equal to the square root of 88 squared minus 20 squared. There you go. So square root of 88 squared minus 20 squared. Okay, now we need to round off to the nearest number. It was 80 and 20, right? 88 and 20, yeah, it was. Okay, nearest whole number. Need to look at this 6, okay? And 6 is closer to, in other words, 85.6 is closer to 86. It's above 5, so we're going to round up. So the answer is approximately, let's make squiggly lines, approximately 86. And that will be your answer. Okay. All right. Next one. Take a look at this one. Again, we want TR. Okay. We want TR. So in this case, same thing. We got, wait, did I literally have the same one? Hang on a minute. 72, 75, 29, 88. Oh my God. You guys, I literally have this. I picked it and didn't look. So there's no really point in doing this one. So I'm just going to hope that your Pythagorean theorem is good. Okay. All right. So this one says identifying side lengths that give right triangles. Determine whether the triangle with the given side lengths is a right triangle. Well, if it's right, then a squared plus b squared will equal c squared. You can check it. So all you need to do is identify the c. C is always the hypotenuse, which is equal to the longest side. Okay, so my C is going to be this one right here. So I have to check 16 squared plus 30 squared and see if it equals 34 squared. That's all. Okay, so here's my trick. 16 and 30, right? So I would go, actually, I won't show it that way. 16 squared plus 30 squared. Is that right? 16 and 30? Yeah. And we want to know if it equals 34 squared, right? So the answer is 85.69, right? Okay, so let me go ahead and put the answer. Oh, no, it's not. It's 1,1156. Now take the square root. If it's 34, we found it. Okay, 34. See, the square root of 1,156 is 34. You can plug it in differently into your calculator. Like you can literally add it all up. You'd be like, what would you get? 1156. Okay. In other words, when I added these, I got 1156. And if I do 34 squared, I'm going to get 1156. And you'd be, yep, it's a right triangle. 5, 12, 13. 5 squared plus 12 squared, is that equal to 13 squared? I'm going to not use a calculator because this one's small enough for me to do. Okay. I know these by heart. You guys, so 5 squared is 25, 12 squared is 144, 13 squared is 169. Are they equal? Okay, hang on, there it goes. So 5 plus 4 is 9, 6, 169 equals 169. Indeed, that is a right triangle. Okay, I'm going to switch colors on you and go to this one, 8, 14, 16. So is 8 squared plus 14 squared equal to 16 squared? Let's try it. 8 squared plus 14 squared equals 260. Take the square root. If it's 16, we're good. Nope, it's 16.12. That's not what we wanted. So this is not a right triangle. Okay, longest side here is 13. Let's try. Let's do blue. Do it that way. Okay. 8 squared plus 10 squared equals 13 squared. Okay, that's 169. That's 100. That's 64. That's 164 is not equal to 169. Sorry. Okay, so that is not a right triangle. See how you do that? I only did one of these because there's 4 problems in one. Just got to get really good with your calculator. All right, this is the last one, okay? And what this is using is the converse of the Pythagorean theorem. And basically it's this, you guys. If a squared, write this down. If a squared plus b squared is greater than c squared, then you have an acute triangle. If a squared plus b squared is less than c squared, you have an obtuse. And that's it. So all you need to do is figure out a squared plus b squared and c squared. So here's what they're having you do it. They're having you do it right here. What is 12 squared plus 16 squared? So you go to your calculator and you go 12 squared. Come on, honey. Plus 16 squared equals 400. So you go, okay, this is 400. What is 20 squared? 400. It is 400, you guys, just so you know. So what kind of triangle do I have? Well, a squared plus b squared equals c squared. So I have a right triangle. Okay, take a look here. 36, this is 6 squared, which is 36. 15 squared is 225. And that equals, I chose to do this one by hand, but you don't have to. 261. 18 squared, 18 times 18, can you see 8 times 8 is 64? Do you see it already? It's not. Okay, oh yeah, you still have to finish it. Whatever. I can't remember 18 times 18 for whatever reason. It's 324. It's like one of those I just don't remember. So 324. So obviously this is not equal, but look, it's less than. A squared plus b squared is less than c squared, which means I have an obtuse triangle. So you just need to find, oh, look, which one is it? It's that one. Okay, take a look at the next one. This is the last one. Okay, so we're checking it. Okay, 5 squared plus 8 squared. That is 25 plus 64, which is 89. And 11 squared is 121. So 89 is less than 121, which means I have an obtuse triangle because a squared plus b squared is less than. Let's try this one. 121 plus 144 equals, you can just plug it in your calculator. I don't care. I'm just doing it by hand because I can. 265. Okay. 14 squared is 200. Oh, crap. What is 14 squared? 14 times 14 is 196. Yeah. It's 196. So in this case, a squared plus b squared is greater than c squared. So in this case, we have an acute triangle. Okay, and that's it for these notes.